Unit 8, Joseph Hansen. 1A. Use a sum formula for finding the sum of the positive even integers less than 200. So what you do is you take 2 plus 4 and 4 plus 6. Those are plus 2. And you do that all the way to 198 because you can't do it to 200 because it has to be integers, positive even integers less than 200. So then what you do is you plug in for S99 equals 99 parentheses 2 plus 198. After that, you get S99 equals 9,900. 1B. Complete the missing parts. Also represent the sum in summation notation. So, what you do here for my summation notation, which is right here. So I put I equals 0 and 2I plus 2. So what I did is I went 2 parentheses 2 parentheses 0 and parentheses plus 2 parentheses 1 parentheses plus 2, which gets you 2 plus 4. Then you take 2 times 2 plus 2, which is 6. And then you do 2 times 98 plus 2, which is 198. 1C. Use a formula for finding the 30th term. So the formula I used was arithmetic sequence. So I got AN equals 2 plus parentheses 30 minus 1 and parentheses times 2. After that, when you subtract 30 minus 1, you get AN equals 2 plus 29 times 2, which gives you, when you multiply 29 and 2, it gives you 58, which is 2 plus 58. So the 30th term would be 60. Write a summation notation to calculate the total number of stacked peaches. So what I did is I put I equals 1 on the bottom, I squared on the right, and 15 on the top. Using the special formula for the sum of the squares of first n positive integers, calculate the total number of peaches again. So, what I did was, I did my arithmetic sequence, and I got Sn equals 240 times 31, which gives you 1,240. 3a. How much money do you have in your account on your 40th birthday? So, what I did is you have to do n equals 40 minus 19, which equals 21, because you started at the age of 19. So, an equals a1rn minus 1, which is the geometric sequence. So, therefore, you put a21 equals 6,000 parentheses 1.07 and parentheses 29 minus 1. And how you get 1.07 is that when it says in a retirement account that pays 7% annual interest, so the 7% becomes 1.07 when you convert it. So when you combine, when you do the exponent and times the 6,000, you get 23,218 and 11 cents. Fuck, I totally fucked up. Write a recursive rule for how much gets added to your bank account every year. AN equals AN minus 1, parentheses, 1.07, end parentheses. 4. Solve. So what I did is I took 2 minus 3 squared plus 2 minus 4 squared plus 2 minus 5 squared, so forth till I got 2 plus 10 squared. And when you multiply all those out and add them together, you get negative 364. What is the 100th term for this sequence? 9, 4, -1, -6, -11. So from 9 to 4 and from 4 to -1, it is a subtract 5 difference, minus 5 difference. So therefore you get AN equals 9 plus 100 minus 1 minus 5. Then you get 9 plus 99 times -5, which equals -495. And after you add the two together, you get -486. 6. What is the 12th term for this sequence? 3, 12, 48. So from 3 to 12 and to 12 to 48, it's a times 4 difference. So therefore, I take the geometric sequence, and you get AN equals 3 times 4 to the 11th power. You always do exponents before multiplying, so you get 41,943.04. And when you multiply those two together, you get AN equals 1,200,125,82912. Number 7. What is the sum of all 150 terms from question number 5? So what you do is you take SN equals 9 plus -727 over 2, which then gives you 150 parentheses -727 over 2, which when you divide down gets you -3,635 times 150. So your answer would be SN equals -54,525. Number 8. What is the sum of all 20 terms from question number 6? So what you do is you take the geometric series and you say x equals 3 parentheses 1 minus 420 over 4 end parentheses, and when you multiply and divide all this together, you should get n equals 1.09951162,800. What I learned best from this unit was actually how to use arithmetic sequences and how to use my bank account wisely and what insurance to use. Thank you, Mr. Soohoo.